Yeah, Parthi, you had a question.
Like in Shruti ma'am's and my project, like social correlation of hypertension with social determinants.
Hmm?
In that, for that I have tried. I have just for the being of practice, I have took this iris data and
Yeah,
made some training set and testing set.
yeah,
For the up to that I could able to perform. So the next one, what AI suggests is random forest. I don't know what to do with
yeah.
that model
Uh, okay.
RF model creation.
I think, Parthi, I think you will be the
Yes.
one who is going to benefit the most from Brandon Flon's lectures.
Okay.
Okay. You remember?
Yes, sir.
Yeah,
You have sent.
yeah, yeah. You will be the one who is going to benefit the most. The reason is uh,
Okay.
Shruti, Frederick sir, and Subarna, they already had some have some understanding about. I think Anand, you also can have a look at those because they'll give a very good foundation. The thing about Shruti, Frederick sir, and Subarna is that they already have some kind of understanding about what he says. Okay,
Okay.
but
Okay, sir.
uh, that's a good thing and a bad thing. Okay, since they
Mm.
already know something, it will be very difficult for them to unlearn things.
Okay.
But you are starting afresh, right?
Yes, sir.
So all the concepts and everything, it is only going to be much clearer, much more foundational for you. Uh,
Okay, sir.
Random forest and all is it all comes down to a kind of a regression model. Okay, but
Okay.
then
Yes.
you need
Sure.
to be very, very, very thorough about everything else. Like last time we were talking about distributions. Were you there?
Yes, sir.
That discussion?
Yes, sir. Yes, sir.
Yeah. So yeah, I think it's fair enough if um, see the first thing that you need to do when you're actually trying to do a uh, random forest is basically a classification model, right? What it
Oh,
does is,
yes.
I mean, it tries to classify something as yes or no, or high risk, or yes, or
Okay.
disease present or absent, or whatever, right?
Mm.
So if you look at the different kind of variables, you have a numerical variable, you have uh, uh, categorical variable, you have a nominal variable, you have a Boolean variable, or you have something called as a dichotomous variable as well, right?
Okay. Mm.
Dichotomous, you understand what's a dichotomous variable?
No, sir. Like
Dichotomous means only two options are possible. Okay.
two categories, that kind of things. Yeah.
Yeah, only two
Level.
things is
Yes.
possible. Yeah, like for example, somebody is either diabetic or not. But then you may
Yes.
ask, what about pre-diabetes?
Mm.
So we are not going to complicate things with that. Okay. Like for
Okay.
example, alive or dead. You cannot say, okay, what if he is on the way to death?
Okay.
So things like that, right?
Mm.
I would not put gender here because gender, if there is a third gender, or nowadays,
Yes. Oh.
gender is fluid, right? You can be all and one at the same time and things like that. So there are all debates that we would not want to get into, especially when we're working with sensitive communities like
Yes.
LGBTQ plus A. Now, I don't know how many alphabets are there, but yeah. My point being is that you need to understand the different kind of variables to really understand what kind of problem you're looking at, in the sense
Oh.
that there is an explanatory variable and an outcome variable. Okay, everything that you're
Yes.
trying to do, there is always an outcome variable, right?
Mm. Mm.
For
Yes.
example, the outcome could be diabetes, the outcome could be
Mm.
death, it could be survival, it could be the type of delivery, cesarean or normal, it
Okay.
could be uh, uh, pass or fail, right? Anything can be related as an outcome. Even the blood pressure can be an outcome variable, which is a continuous variable, right?
Yes. Yes.
So outcome variables are anything can be an outcome variable. Similarly, anything can be something called as a explanatory variable as well.
Okay.
Okay. I hope I'm making myself clear. Okay.
Yes, sir.
So there are two different kinds of variables. If you think about it in the model building landscape, there is an outcome variable and an explanatory variable.
Explanatory variable.
Shruti, do you know other names for this? Is it exposure variable and or what is that called? It's independent and dependent variables, right?
Okay.
You must have heard these terms, right, Parthi?
Yes, sir. Manipulated variable. All are same also. Which
Sorry,
can be manipulated variable, that explanatory variable, independent variables that can be manipulated by the researcher.
Yeah, I don't know if a manipulated variable or manipulative variable is a standard term.
Okay, sir.
Definitely dependent and independent is a standard term.
Okay.
And
Okay.
outcome and exposure is a standard term, right?
Okay.
For
Yes.
example, if your outcome is cancer,
Okay.
outcome would depend on something, right?
Yes.
So outcome would usually depend on your exposure. So if you're thinking about, for example, the classical example of lung cancer, what could the exposure be?
Cigarette smoking. Any occupational misses, sir.
Yeah, cigarette smoking. It could be any kind of maybe family history could be an exposure. Even higher age is an exposure. See, exposure does not only mean that a person is exposed to that, right? Anything that influences the outcome is an exposure variable. I mean, in terms of what we are discussing right now, because you need to contrast it with the similar terminologies called dependent and independent variables, right? For example, cancer is dependent on your age, isn't it?
Yes, sir.
I mean, at least lung cancer, you tend to say that a person who has higher age has higher chances of having lung cancer, right? A person who's 80 years old and 80 years old, who would have higher chances of lung cancer?
80 years.
Yeah, a person who's 80, right? So age is something called as a exposure variable. Or we are talking about dependent and independent variables. Now, can you tell me which is dependent and which is independent in terms of lung cancer and age?
Lung cancer is dependent variable. That is outcome.
Yeah, lung cancer is dependent on age. It cannot be that okay, just because you have cancer, your age is going to be 80 from 80 to 80 years old. It's not going to turn that way, no. Lung cancer is not dependent on the age. Age is dependent on lung cancer, isn't it?
Yes.
Are you able to see the whiteboard?
Yes, sir.
Okay.
It's
So if you really have to write it, right? If you really have to write it, I am not very good at handwriting. This is the first time I'm trying out. Is that right? Yeah. Lung cancer is dependent on age. Okay, that's the connotation, right? Something is dependent on something, or we can you give me another example of dependent and independent variable? Am I audible?
Yes, sir.
Yeah,
Genetics.
any other thing. I'll give you one more example, maybe you'll get the hang of it. Sorry. Diabetes is dependent on what is diabetes dependent on? Obesity.
Obesity.
Okay. Can you give me another example?
Cardiovascular disease is dependent on hypertension.
CVD is dependent on HTN. Okay, fine. Then you can think of some more examples. Dental caries are dependent on amount of chocolate you're eating. Okay, but also think, just 1 second, I think there is somebody at the door. Yeah, sorry. What was I saying? Yeah, just think about it. Do you think, yeah, we talked about obesity being a explanatory variable or a independent variable, right? In this context of diabetes, obesity is a
Dependent.
obesity is dependent or independent? Obesity is dependent on diabetes, is it?
Diabetes is dependent on obesity.
Yeah, diabetes is dependent on obesity, right?
Yes, sir.
In this context, right? But then, just 1 second. I don't know if I can increase the size of this. Yeah. So if you see now, is this possible? Can hypertension be dependent on obesity?
Yes, sir.
Yeah. Agree? No.
Yeah, of course.
Yes,
Yes.
sir.
Okay. Obesity is dependent on physical activity. Is it possible?
Yes.
Sorry for the, yeah. Okay. So when I say dependent on independent, don't just think of it as, okay, age can only be a dependent variable or an independent variable. Obesity can only be a dependent. It's not that. It's the context that you're talking about, right? Obesity can be a dependent variable and also it can be an independent variable, right? But depends on where we are talking about. It cannot be dependent and independent on the same, equation, right? It can be. Those are some caveats that we need to understand, because which came first, the egg or the chicken, right? Or you can say, what is dependent? Is it diabetes causing hypertension or hypertension causing diabetes, right?
Yes.
You get my point?
Yes.
Yes.
So
Yes,
there
sir.
are a number of things that are nuanced in terms of epidemiology, but what I'm trying to really make you understand is that there might be, okay, how many of you had time to look at the primers again? The different variables. Do you even have, do you even know what primers we are talking about?
Primers you have been sent in the first class.
In the first lesson, right? The primers. They would hardly take 5 minutes to go through. Did you have a look, Shruti?
Yes, sir. Yes, sir. Actually, I'm having unstable network. Yes, sir.
Okay. Anand, I would suggest that you also have a look. Okay.
Okay.
Do you have the link or you want us to share again?
I think first link is sent through mail. Is it?
Yeah. It's through the mail. Yeah. Yeah, I think you can just go through those primers again. No? It'll be easy now. You will understand things very easily now. It won't take so much time. It'll hardly take you 10 minutes. Okay. Anyway, so the kind of variables that we talked there was, numerical. Even yesterday we were talking about numerical variable, character variable, date variable, logical variable, or things, factor variable. These are all we were thinking, right? But in epidemiology, we think of it as outcome and exposure, or dependent and independent. isn't it?
Yes,
Okay.
sir.
So here things can be interchangeable, but once you look at the left side of the equation, right? Lung cancer, diabetes, CVD, hypertension, obesity, right? Look at lung cancer. Lung cancer, what kind of variable can it be? We know that it's a dependent variable, right? But come back to the type of variable it can be. Can it be a numeric variable?
No.
No. Yeah, it cannot be a numeric variable, right? It's not lung cancer is 147. It's either yes or no, or present or absent, right?
Yes.
So it's a dichotomous variable or a Boolean variable. Boolean means true or false. Okay. Or it could be character variable, but you know that something is yes or no, right? It's a dichotomous variable. There are only two possibilities here. Either you have lung cancer or you don't have lung cancer, right?
Hmm.
What about diabetes?
Diabetic has values.
Yeah, but then I need to be very clear here. Okay, I can write the same thing as
More now.
HbA1c is dependent on BMI. Is it even visible?
No.
Okay, what I'll just use a. Is there a way?
We have to move the screen. Then only it is visible.
Okay.
Yeah.
Is it better? Okay.
Yeah, just slide.
Okay.
Okay.
Diabetes is dependent on obesity, right? But now I have written it in a different equation. I said HbA1c is dependent on BMI. HbA1c is an indicator of diabetes, yes or no?
Yes.
BMI is an indicator of obesity, yes or no?
Yes. Yes.
Now, just contrast these two, right? The diabetes and obesity and HbA1c and BMI. The representation of the variable diabetes can be in many ways. It can be diabetes, yes or no, right? It can be diabetic, pre-diabetic, non-diabetic, isn't it?
Yes.
Or within diabetic also you can have uncontrolled, controlled, unknown, whatever. Unknown status is also possible, right? Diabetic or no, it need not be yes or no. It can be unknown also. Some person don't know if he is a diabetic or not. It could be possible, right?
Yes.
But yeah, even it can be represented as random blood sugar values, fasting blood sugar values. Because how do you know if somebody is diabetic? You actually take some value and you categorize it. Diabetes can be depicted in from three different variables, right? It can be depicted from random blood sugar, from fasting blood sugar, and HbA1c values, right? If your random blood sugar is more than 200 milligram per deciliter, then you are considered to be diabetic. Okay. If your fasting blood sugar is more than 126, then you are considered to be diabetic. If your HbA1c is more than 6.4, then you are considered to be a diabetic. Okay. Any of these, not all of them, any of these would mean that you are a diabetic. Am I right or wrong, Shruti? Okay,
Yes.
Shruti has internet connection issues.
Yes, sir. Yes,
Okay.
sir.
Okay.
I'm
So-
actually joined from phone also. So,
Okay. Okay. So, what about the obesity, right? Obesity, it could be present absent. It could also be normal. What are the categories of obesity? normal, overweight,
Obese
obese,
class 1, obese.
yeah, obese and morbidly obese and things like that.
Morbidly obese. Yes, sir.
Yeah, it's again dependent, I mean, based on BMI, isn't it?
Yes, sir. Yes, sir.
But you can ask the question, what is BMI dependent on?
Height and weight.
BMI is dependent on height and weight, right? So, what I'm trying to get at is it really you need to have that kind of clarity, in the sense that when you say diabetes, what do you really mean by diabetes? Is it fasting blood sugar more than 126, or is it HbA1c greater than 6.4, or is it random blood sugar more than 200, or any of the above? Isn't it? Similarly, when you say obesity present, absent, or whatever, is it based on BMI? There might be other classifications that we don't know of, but we usually use the WHO classification. There is an Asian classification also. That is also used. But anyway, similarly, if you look at obesity being dependent on physical activity can be measured in many ways. Can anybody tell me what are all the different ways physical activity can be measured?
Number of steps taken. W.
Okay, number of steps. Okay, then you ask the
Calories burnt.
Oh,
yeah,
exercise.
you ask the person what is your kind of activity? Is it moderate, sedentary lifestyle, or
Right.
whatever, things like that, right? And there are other ways also. You calculate your MES or something like that. No, there are some values. No,
Yes, sir.
I also don't remember, but yeah, based on those, try to come up with a indicator saying that you're, having this many physical activity units and things like that. Okay. So, yeah, what we are trying to say is that every variable can be different kinds. It can be nominal, ordinal, qualitative, quantitative, numeric, double, continuous, or discrete, or anything. But you need to classify it as your dependent or independent variable. Okay. You get my point?
Yes.
Okay. So you had a question, Parthi, that
Yes.
when you were looking at the iris data set, you had a question that you want to look at random forest, right?
Yes.
And you tried to
Actually,
split you tried to split the
I
data.
tried to split, sir. Split has happened. Then I tried to learn about that random forest function.
Okay.
So there was the confusion.
Why do we split the data?
Because one data is to
Thing that we usually learn. I mean, when we actually learn in epidemiology, there is no textbook talks about splitting the data. Okay. That's one of the drawbacks in our community medicine education, is that we are still stuck in 1986. Okay. We don't usually advocate that we need to split the data and validate it and things like that. Isn't it? You have done logistic regression, no? Okay, I think she must be having issues. Yeah, anyway. How did you split the data, Parthi?
using carrot package. So CARET, I think.
Yeah, carrot stands for?
That I didn't see, sir. Actually.
CARET stands for classification and regression trees.
Okay.
Yeah. So you need to be little well versed. There'll be 30,000 packages available on CRAN.
Okay.
And you really need to know what exactly, why exactly, and how exactly. Okay.
Okay.
That's why I be a little more specific on. Anyway, the carrot package is a good one. It's been there for a very long time. Again, that's again based on a conventional way of doing things. You know? If you really want to go ahead with modeling, the tidy way, the package that you need to look for is tidy models.
Okay.
TIDY models, MODELS. Okay. I think it's Max Kunt and Julia Selje are the authors of the package. Yeah.
Okay.
Yeah. Anyway, wonderful people. Yeah. Coming back to carrot. Why do we split the data, right? What we do when we are working with data is that we only have how many rows is the iris data?
149 rows, 149 entries, I think. So around 150.
149 observations, right?
Mm.
149 observations, and then you split it based on 80-20 or 70-30.
Yes, sir.
Okay. So the conventional approach for any kind of regression is to take a subset of the data and you build a model on that. Okay. You theoretically, what you say is that, okay, for example, my theory says that diabetes is dependent on obesity. Okay. But then you need to test it also. Na? Is it really dependent or not? If yes, how much? Right? Again, I think that we are delving into the theory of regression today. Are you all comfortable with regression?
Yes, sir.
I'm not, I have to study it.
Anand, how about you?
No, I don't know much, sir, but I can.
You have heard the concept, no? Okay. The way regression works is that y is dependent on a plus b of x. Okay. What does that really mean is that let us think that this is our y-axis, right? This is our x-axis. Let us take that x-axis is maybe age. Y-axis is height. Okay. Age is like 0, 1 year, 2 years, 3 years, 4 years, 5 years, etc. So as age increases, what is the relationship that happens to height? Will it increase or decrease?
Increase up to a level.
Okay. So it increases up to a level, right? It increases up to a level, and then there might be a plateau. And maybe in the extremes, when there is kyphosis and scoliosis, there might be a small decrease in observed or measured height. We will not get into that. Okay? But there might be an increase, and this part looks like a straight line, right?
Yes, sir.
So the relationship between height and age, to an extent, is linear. Okay, linear, right? When I say linear, this is what I mean by linear. In the sense that height, which is y, is dependent on something plus something. Okay. But the second something, x, is nothing but age. Okay. Am I confusing you guys?
No, sir.
No, sir.
I know.
No, I'm worried about Anand because these are new concepts to him. These I'm trying to bring in a different perspective, not the formal way of bringing things. Anyway, so Anand, when somebody is born, his age is how much?
0.
0, or her age is 0, right? But what will be her height or his height?
There is somewhat
Somewhat value, no, some value will be there. It might not be 0, na?
Yes.
Okay. So when somebody is born, the residual height they have is nothing but your A or intercept. So this part, whichever you're seeing here,
Not starts from 0.
is A. Or it is in the terms of regression, it is called, there are two names for it. Okay. It's called the constant. Okay. Or it's called the intercept. We can use the word intercept. INTERCEPT. Okay. Intercept. So Y is dependent on something. Intercept plus something of age, right? So as age increases, height will also increase.
Up to 11.
But how much? How much will it increase? If age is 1 year, it might be something. If age is 2 years, it might be something plus something, right? So the B here, which is called the slope, SLOPE, or coefficient. Okay, it's called a coefficient or slope, is nothing but this, the angle here. Okay, so if you really have to interpret this, you would actually say that Y, which is the dependent variable, is dependent on, Y is dependent on, height is dependent on the intercept plus
Coefficient of
the slope of age. Okay. So for every 1 unit change in age, how much will Y increase? Okay. So for example, let us consider that the slope of this equation is 0.2, and the height is, maybe somebody is born with 50 centimeters of height. Let us assume. Okay, 50 centimeters of height is this, and whatever. So if you plug in these numbers, so what will be the height at 0 age?
50 centimeter.
50, because this is nothing but 0. 0.2 into 0 will be
0.
what is 0.2 into 0? X is 0, na? Age is 0 age we are looking at. So this will be nothing but 50. What will be the height at age 1? 50.2. Why? Because 50 plus, okay, let me go back. 50 plus 0.2 into 1, isn't it? B into X.
Yes, sir.
Age 1, his or height is going to increase by 0.2 units, isn't it? So that will be 50 plus 0.2. It will be 50.2. Correct? Now you need to tell me what will be the height at 2 years of age. $50 plus
0.2 plus
0
0.2
into,
2.
what is the X? 2 years.
2 years.
So that will be
3.4.
50 plus 0.4.
Okay.
So it will be 50.4, isn't it?
Yes, sir.
What it will be at 3 years of age?
50.6.
20 years of age?
60.
Yes.
60 centimeters. Okay. I'm not, don't take my, this 0.2 is not a very good coefficient. Okay. But I'm just trying to give you an idea what it means to be a coefficient. For every 1 unit change in X, what will be the change in Y? That is dependent on slope, the slope and the intercept, right? Sometimes intercepts are meaningless. You really don't have to worry because they are constant, right? You're only worried about the slope. Okay. So now let me just complicate this. What we are looking at right now, y equals to a plus bx. Okay, a plus bx is the simplest form of linear regression. That's why it's also called as simple linear regression. Am I clear here?
Yes.
Or do I have to repeat once again?
No, sir. Just if I say y is dependent on a plus bx, in which a is x intercept, right?
Once
Um,
again, let me please once again say that. I'll try to clarify once again. Yeah.
Y is dependent on a plus bx.
Y is dependent on x. That is it.
X.
Okay. Y is dependent on x. That is the main function. But now what we want to know is how is y dependent on x? What is the relationship?
Yes.
Okay.
Okay.
Now we are saying that for every 1 unit change in x, how much is y changing?
Okay.
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 For every 1 unit change in x, how much is y changing? For that, we are multiplying x by a value called slope, which is beta coefficient, and adding it to the intercept. Okay.
Yes,
Sometimes the intercepts are meaningful. Okay. That we know that, okay, when a baby is born, the average height is this. Okay.
yes.
But sometimes the intercepts don't really matter because we are only focused on the slope. Okay. I'll just give you an example. There is a diabetic and a non-diabetic. Okay. Now you want to find out what is the influence of hypertension in his or her cardiac health. Let me write that as an equation. Will it be okay?
Okay.
So y, which is CVD, okay, or CAD, let us call it CAD or CVD, okay. Coronary artery disease, which is CAD. Y is dependent on diabetes mellitus plus hypertension. Okay. CAD is dependent on diabetes mellitus plus hypertension. Is this something that you're interested to see? HTN, right? Yeah, forgive me for my clumsy fingers. Okay. Do you think a person who is a diabetic, his risk of CAD will be the same as a person who is a non-diabetic, given their hypertension status is same?
No.
Okay. Now let us draw a thing. Let us think that this is CAD. Okay. This is a DM or hypertension, whatever. There might be two differences. Maybe this person is diabetes mellitus positive. This person is diabetes mellitus negative. As his or her BP increases, the risk of CAD is much more higher in a person with diabetes mellitus as compared to a non-diabetic person, isn't it?
Yes.
I know it's a complex thing. I think I've jumped the gun, but I mean jumped the gun in the sense I've tried to tell too much in a single step. But the reason I'm trying to do this is that now you think about this simple equation not equal to okay.
Okay.
So earlier diabetes was dependent on obesity. Okay. Now we are saying CAD, cerebral vascular disease, is dependent on diabetes mellitus and also hypertension. Okay. Now, how many dependent variables we have now? We have
CAD is a
one
dependent.
dependent variable, CAD. Whichever is on the left of the equation is always the dependent one. How many independent variables we have?
Diabetes mellitus and hypertension both are also dependent on.
Two independent variables.
Okay. Yeah, that's the concept I wanted to clear. Okay. Yeah.
Sorry, sir.
In
Is it
this
just
context-
mine or the screen is blank for me? Is it?
Sorry,
You have to move the
Sorry.
screen.
Have to move the screen now. There's a cursor.
Okay.
you have to move or I have to move?
Okay.
No, so everyone has to move. So for
Okay, you guys have to move on your own, is it?
yes.
Yes.
Okay, I'm actually drawing unnecessary lines. I don't know why. Okay, if you, I'm circling the thing. Come back to the first thing that we saw. Lung cancer, age, diabetes, obesity, CVD, hypertension, all of that, right? See, hypertension was dependent also and independent also, na?
Yes.
But it depends on the context, right?
Yes.
You get my point?
Yes.
Yes.
Obesity was also dependent and independent, but the context was different.
Okay.
You get my point?
Yes.
So, what my question was, a person who is at risk of heart attack, do you think okay, let me frame it properly. The relationship between heart attack and diabetes. Okay. Tell me what is dependent and what is independent.
Heart attack is the dependent variable.
Heart attack is dependent on your diabetic or not. Correct?
Yes.
Yes.
Now, heart attack and hypertension. What is dependent? What is independent?
Heart
Again,
attack is dependent.
dependent.
Hypertension is independent in this context.
Hypertension is dependent. Okay. So if I have to break this down, so I can write it this way, right? That CAD is dependent on diabetes mellitus. Correct? The first one we talked about. Or CAD is also dependent on hypertension. Okay, you agree with these two things?
Yes.
This is what you said, na? So here, when CAD was the dependent variable, diabetes took the role of independent variable.
Dependent variable.
Okay. Or in the second one also, when CAD took the role in this context, when CAD was the dependent variable, hypertension was the independent variable. Okay, now can I combine this? I hope you're all looking where I'm typing, I'm writing.
Yes.
CAD is dependent on diabetes also and hypertension also. the first above two equations are both examples of simple linear regression,
Okay.
because only one thing is dependent on the other.
Hmm.
Forget about the slope. Sorry, not about the slope. Forget about the intercept, right?
Yes, sir.
Second one is an example of multiple linear regression. It's no longer simple because now two things are involved. You have two independent variables, and one always dependent variable is one.
Yes.
Okay. I don't want to get into the complexity of, can there be more than one dependent variables? Let us not go there. But for the context of this, I'm just adding one layer of complexity, saying that it's not just diabetes that somebody is, influencing. It's not diabetes that is influencing, not only diabetes that is influencing heart disease, also hypertension is influencing heart disease. Okay. So now if I have to write this as the same equation that I did before, how did I write it before? Y equals to A plus BX. Isn't it? So now you have to write it again. I would write it as this. Y is dependent on A plus B1 x1 plus B2 x2, where x1 is diabetes mellitus, x2 is hypertension. Am I clear?
Yes.
Yes.
Shruti, am I confusing you?
No, sir. I just have blank screen. That's all. I'm listening to what you're saying, sir.
Okay.
Ma'am, there is a
Yes.
cursor with search name. You could move along there.
No, I'm from mobile and I can see your
Okay.
names like it's there, but the
Okay.
white side.
Yeah, anyway, we are sorry that you cannot see that. I'll require you to follow me. Now, can you see?
No, sir. I can just see your name like written in a tablet
Okay,
thing, but
okay. I get it. Maybe the font is too small. Can you zoom it?
Font is already big, I think.
I think it's at 400 zoom. I think is it something with mobile? I don't know. Because my laptop has completely switched off now.
Yeah, 400. I think, Shruti, you have to either put it in ICU or you have to, do something about it. You know?
Yes, sir. I just told it's constants from yesterday and then it just switched off. It's like now worse.
Is it because of the increase in RAM? It's not able to take it.
I don't know, sir. I called them up. They said it's nothing related to that. The technician people, but I couldn't take my laptop there because it's flooding in Mumbai today. So
Oh, okay. Yeah. Okay. Yeah. I hope that just because I've introduced this B1 x1 B2 x2, you're not confused. You know what
No.
I mean by B1 x1 B2 x2, right?
yes,
B1
sir.
here is the slope that diabetes is involved with. B2 is the slope that hypertension is involved.
Yes, sir.
Okay. So
Okay.
now what I mean to say, now let me put this in a graphical representation. Okay. This is the risk of coronary artery disease. Okay. Now let us assume that this is hypertension. This is the blood pressure values. Let us assume. Okay. 120, 160, 200, 240. Okay. I think these are too much of values. No, let us reduce them a little. 120, 140, 160, 180, 200. Okay. These are the systolic values. So I have a person who is a non-diabetic person. Okay. So as BP is increasing, do you think, Anand, are you able to write something?
Sorry, sir, where to write?
Parthi, are you able to write something? Can you try?
Yes, sir.
Yeah. Yeah, I can also. There's
You can
there
write,
is like
but we are not able to see you, is it?
yeah, I draw it.
Okay, you can also write.
Yeah,
Okay,
sir.
why don't you guys change the color?
Sure, sir. I will use red color.
Yeah.
Where is the color option?
In the pencil tool only, sir. You could just click that and there will be a color option at the bottom.
Okay. Okay,
Okay.
blue
Okay.
color.
Now assume that I'm asking you to draw a line, regression line, just like we did for hypertension, sorry, height and age. I'm now asking you to draw the line for coronary artery disease or heart attack, let us assume. Okay. Heart attack and hypertension.
This 120, 140, 160 is common for both diabetes and hypertension, sir. The values, reference values.
I'm assuming that this person does not have diabetes. Okay.
Okay.
Draw a line. How do you think it will be?
And use this.
So y-axis is CAD, right?
Yeah, y-axis is, let us assume it is the risk of
Getting CAD.
yeah, getting heart attack.
So,
Now, this is a normal person with no diabetes, right? Okay. Okay, now Anand, are you able
yes.
to see the red line?
Yes, sir.
Okay. This is what Parthi, I requested Parthi to do is a normal person who does not have diabetes, who just has hypertension. As his BP is increasing, this is the risk of having heart attack. Okay. Let us assume that y-axis is 0 and 1. Okay. 0 means 0 risk and 1 means 100% risk. Let us assume. Okay. As his BP is increasing, his risk is going up. Do you agree?
Yes,
You know,
sir.
when he has normal BP 120, risk is 0. When he has 140, the risk has gone up maybe 10%, isn't it?
Yes.
When his BP is 160, it is now 30%. When his BP is 80%, then risk gone up to 60%. When it is 200, it is 90%. Let us assume, isn't it?
Okay.
Yes.
This is a normal person. He does not have diabetes. Now, my question to you, Anand, is that now assume that a person has diabetes. Do you think his risk will be the same as this person, or will it be different? If it will be different, then where will you put the line?
I think the risk may be different because in addition to hypertension, if diabetes also, then the risk may be increased.
Okay. If it is increasing, then where would you put the line? Maybe, are you having the cursor with you? Parthi, I think you change the color. Huh?
Yes.
Parthi-
I have done that. Like,
Control Z.
okay.
Anand, you have to do it now. I think he's already given you the hint.
Yes, sir. I also
I'm
thought
sure
like
that
the same, but I don't know.
not the same, but why don't you put that?
Sorry, sir. I
Yeah,
tried to
that's
write.
okay. Yeah,
Yes.
that's fine. So what I'm trying to get at is that all of you will agree that the person who has diabetes has a little more higher risk
Right, sir.
compared to a person who does not have diabetes, isn't it?
Yes.
So my point here is, do you think the slope of these both lines are same or different? Slope means angle, na?
Yes, sir. Different. It has different angle.
It is different angle,
Yes.
Yes.
right? So the beta coefficients will be different, isn't it?
Yes.
That's what coefficient means. Na? That is what the slope means, right? Y equals to A plus B1 x1 plus B2 x2, right?
Yes.
So this is for hypertension, this is for diabetes, we know. But you know that a person who has diabetes has greater slope or higher risk of coronary artery disease as compared to a person who does not have. So this is the graphical way what we are trying to represent when it says that okay, a single line is trying to do it, but now when so now I don't want to confuse you any more than I already did. What I'm trying to say is that this is the one of the other simplest examples of multiple linear regression. There are a lot of assumptions that you need to take into account when it comes to regression, right? That is the theory part, which I'm not going to get into. I'm assuming that as you go in your journey, you will be familiar with those assumptions, because this is not a statistics lecture. This is more of a conceptual kind of a thing, isn't it? So, you know the assumptions of normality, no? Can anybody tell me what are the assumptions of normality? Normal distribution, you know, no? Normal distribution.
That 68% of the data falls in minus 1 to plus 1 That one we're asking.
Yeah. I mean, yeah. If I say that this variable follows a normal distribution, that means you're assuming that it is a symmetrical distribution where 68% of the data falls between plus minus 1 standard deviation, 95% falls between plus minus 2 standard deviations, and 99 point something percent falls between plus minus 3 standard deviations, and the mean and the mode and the median are almost the same, isn't it? Mean equals to median equals to mode, right? These are all the assumptions that you take when you say that something follows a normal distribution, and based on that you're doing the statistical test, isn't it? Similarly, there are a lot of assumptions when you say that this variable is dependent on something, or you apply a linear regression model, right? When you say I'm applying a linear regression, that means there are n number of assumptions that you are assuming already. You're assuming that these variables are independent of each other, okay, and they don't have multi-collinearity, right? There are a number of other things. I'm not going to go into the theory. Similarly, when you go for multiple linear regression, there are some assumptions that you assume, thinking that this is how things are. You assume that first of all, it follows a normal distribution, which it should. If it does not follow a normal distribution, then you need to see, like I told you, right? This is a normal distribution, okay? This is a Poisson distribution, okay? Wherever time is related, it follows a Poisson distribution, okay? There are other kinds of distributions. There is a chi-square distribution also. There is a T distribution. There is a Z distribution. There is an F distribution. There is a gamma distribution. There is a Weibull distribution. There are n number of distributions: beta normal, binomial, negative binomial. N number of distributions are there. Each of these distributions has their own assumptions, and only when those assumptions are satisfied, then you go for that kind of a statistical test. Am I clear?
Yes.
So the theory behind all of this, I would assume that as days progress, as you learn more and explore more, you will start to gather this insight. See, when I have to draw this Venn diagram. How many of you have seen this diagram?
It's visible, sir.
Sorry. You've seen, nah? It's not a very good diagram. But yeah. So this is called the Venn diagram of data science. Okay. Data science is here in this middle part. Okay. This is statistics. Your knowledge about statistics. This is computer science. Okay. This is your domain. If you're a public health person, then your domain expertise is public health. If you are an environmentalist, your domain expert is environmental science. If you're a climate activist, if you're a financial advisor, if you are an economist, so this is your domain. It can be whatever you are. But this is the main thing that is purely called data science. Okay. There is no data science without statistics. There is no data science without computer science, which includes IT and all of that. Okay. But foremost thing that you really need to be a data scientist is the domain expertise. Nowadays, all colleges are, saying that you be a data scientist, you do this, do that, right? They might give you statistical knowledge, they might give you computer science knowledge, but who is going to bring the domain expertise? It is your own subject, right? So you need to bring in the domain expertise, and only when you bring in the domain expertise, it is truly a data science work. So you're truly a data scientist only when you bring in your domain expertise. If you're not able to bring in the domain expertise, so for example, this part, you're not bringing in the domain expertise, right? So this is the realm of data engineers or data analysts. Okay. You get my point?
Yes.
Yes.
So I don't want you to be in this domain. I want you to be in this domain. Okay. The center thing, which brings in the applications of whatever you're learning now and apply it in your own work, right? So it might be anything. It might be whatever you're passionate about. For me, earlier it started with looking at endocrinology data sets. I mean, I was working with continuous blood glucose monitoring systems, and we used to put sensors. This is back in 7-8 years ago, when the CGMS and insulin pumps and all were still very new, and we had a partnership with Abbott Systems, and that was before they had this continuous blood glucose monitoring systems. They gave it free for us to conduct free public trials and all of that, community trials. I was very interested in that, and that is where I learned okay, when I'm looking at data that is being collected sequentially, I mean, every 15 minutes I'm collecting the data for 96 days. So imagine, and this is for thousands of patients. So all of this, we are also collecting data on their diet, their physical activity. We had sensors there, Fitbits and all of that. This was before Google bought Fitbit. I hope you know that Fitbit is bought by Google.
Yes.
Yeah. So this is even before that, and we had to bring in data on their quality of life. How do they perceive their medical adherence? Their how many drugs are they taking? Are they on insulin? What is their peer support group? Do they have a very conducive environment? What about their financial status? Are they elderly? Are they financially independent, or are they dependent on their children? So all of these comes into play. Okay, but then we realize that, okay, this is not just taking the sensor data and trying to come up with whether this person's glucose hypertension or diabetes is cured or not. it's more complex than that. And that is when we realize that it does not require just your domain knowledge, but it also requires multiple inputs from statistics, from computer science. How are you going to bring in these multiple formats of data and make sense out of it? And you need to be robust and in terms of statistical analysis and things like that. Okay.
Yes.
So the point being, I want you to work in the center area. So domain expertise, you're building it. It will come with experience. But if you don't have the statistical knowledge, computer science and all, it will come again as you grow. Statistics also will come as you grow. But if you don't have that effort from your side, it will actually not be a very good Venn diagram. It will be a skewed diagram. It will be somewhere to the side, right? You'll be more of a domain expert rather than having the best of all three worlds, right? I hope I'm making sense.
Yes.
Yes.
Okay. Yeah. So that is for my ranting today. You wanted to talk about random forest, right? But then
I think better I will first study the regressions, then I will ask these questions.
Random forest means classification and regression trees. So what it does, it's going to build. Why is it a forest? Because it is made. What is a forest made of?
Many trees.
Okay. So it builds a lot
Yeah.
of trees, right? It builds a lot of
Decision trees.
cutoff points on its own. Based on this, it will tell you that, okay, 160 might be the best cutoff to differentiate between a diabetic and non-diabetic in terms of risk of this thing, right? Or it might say that, okay, not just diabetes, what if your education level is given now? Okay, whether this person is having higher education or lower education. Based on that, what will be the better cutoff? So it will form many trees and then compare all of them, and then see which of them has the best predictive value. That is where random forest comes in. Am I making sense?
Yes, sir. Okay.
Let me very quickly show you what I really mean by it. So these are examples. Are you able to see? Not yet. No?
Yes.
These
Yes.
are examples of random forests. Right? This is the most tree 1, tree 2. It builds many trees, and then you see which of the best, which of the ones are the best in classifying whatever we are trying to classify. That is why it is called classification and regression trees, CART, or carrot package, CARET. Okay. But then I would want you not to work on carrot. I would want to work you on work on 3D models. 3D models. There's a book also. But then, yeah, this is again way down the line when you actually are comfortable with all the models that you know. Now starting page, and everything is quite interesting. All the concepts that we are talking about will make more sense if you have the theory with you. Are you able to see this?
Yes, sir.
So this is an example of what we have tried to do, right?
Build a model.
Yeah, whatever, right? But then everything starts with a recipe. Yeah, process. So the way tidy models is also written, or the nomenclature is that you build a recipe and you have that recipe with you, so that every time you make the model or you make the soup or whatever, use that similar recipe, right?
Okay.
I don't want to overburden you, but Modern Dive is a very good book for you to start if you really want to really think about the statistical part of statistical inference part in data science, right? Modern Dive, you have a website, it is free of cost. Yeah, basic regression, multiple regression. I think if you have a look at, we already discussed all of this. It will not take much of time for you to go through it, right? He's talking about numerical linear regression involves a numerical outcome variable by an explanatory variable, outcome variable and explanatory variable, right? We already know what this is.
Yes.
So if you guys tell I don't know, I'll commit suicide now only. I think we have spent enough time, no?
Yes, sir.
Yeah. Anand, I'm pointing out to you only.
Yes, sir.
You know what's an outcome variable, no?
Yes, sir.
Okay, I think you don't want to kill me. That's why you're saying it. Okay, I think I know that it's the first time for you to listen to all this, but at least you're not scared, and it might take some time for you to get comfortable with this nomenclature. But this is just the concepts that we just broken down, and once you read the literature, you'll get more sense out of it, because these are the things that we talked about already. See, slopes, parallel slopes. Yeah, if there is only one thing, then we call basic regression. We only consider single explanatory variable. Multiple regression is where we have consider more explanatory variables, x1 and x2. That we already did just now. It can be 3, 4. The concept is the same. Yeah. So, yeah, I am looking for a. These are all examples and working examples, and there is a lot of theory and things that you need to also go through, because how do you know that a model is correct? And there is something called as overfitting, underfitting. A lot of other things are also there. But yeah, multiple regression also does the same. You see, this is an example of what we did, but instead of diabetes and present absent, they took male, female. And this is nothing but the slope. The slope of male and female is different, right? You must be thinking, why is the line upside down? Because it is negatively correlated, right? That means when one is increasing, the other is decreasing. When X is increasing, when age is going up, the teaching score is going down. Isn't it? That means it is negatively correlated. Yesterday we talked about correlation, and also we talked about an extension of correlation called autocorrelation. Isn't it? Okay, I'll not go into the interaction and other terms, but yeah, beta naught is intercept, B is slope. Yeah, these are all things that we already talked about, but once you actually go through some of the previous resources that I shared, I think I was also a little yeah, I should have insisted that I should have been more assertive and insisted that you go through them and be very strict. Then you would have gone through all of that and we would have been in a better place. But I think that there's nothing to lose now also, because we are in a self-paced kind of environment now, right? Yeah, okay. So
these graphs, I have a doubt.
Yeah.
In the graphs you drawn earlier, and in the graph just we saw earlier, just above, in which the gap from 0 to first value, that means if 0 to 30, it is not in size with the other. That means if the next value is 30 to 40, there's a uniform size, 30 to 40, 40 to 50. But the space between the 0 to 30 is not in uniform with the others. So how it is
So that is intercept only. That's not if you see 0 to 30 is not even there. So we have removed the intercept here. So if you actually extend this line to 0, so this will be 20, this will be 10, this will be 0. So it will be somewhere over here. Then you will get the intercept. Intercept will be around, maybe if you draw a line like this, it will be around 4.5 for males, and for females it will be maybe around here 5 point something. And let us look at the intercept, what it is here.
Okay, sir. So the output will be just like the same, or is it a cropped image?
You have the control. You have the control. If you want it from 0, you can definitely put it from 0. You can, okay, we have not talked about that, but it's called so there are limits you can set. You can say that the limit for x-axis is 0 to 100. So it will definitely plot from 0 to 100, even though there is no data. The axis will be there. Okay, and then you can set your y-axis as well. I'll just show you. Yeah, anyway, you can definitely set the y-axis, x-axis. Yeah, Parthy, any questions? Okay. So now what are we going to do today? Are you going to share your screens and work on yesterday's thing? Or would you prefer that you do it on your own and then we can have a more productive discussion?
Yes.
See, I think time for spoon feeding is over now. Now you have to utilize the most of my time here. Right? I think enough carrots, chocolates have already been dangled in front of you. Now you have to be a little more hungry. Okay, I think Lokesh is here. Lokesh, I know that you have joined a little late. We were just, bouncing ideas and clearing our concepts on regression.
I didn't start. I didn't understand that.
Yeah. I think if you have time, you can look at the video if you have.
Yes, sir, definitely.
But if you guys are up for it, why don't you continue working on yesterday's session, the R markdown. Maybe I've already shared the screen, RMD for of yesterday. You guys came up with all the answers for yesterday. Do you think you would want to explore each of the further questions, or would you want to look at something a little different, or what? Because it's totally up to you guys.
Can we look at something new?
Sorry?
Can we look at something new?
No, I cannot hear you. Please. Parthy, you're saying something?
Yes, can we look at something new other than yesterday's?
Okay, something new. Okay.
Yes.
Okay, I have a again the
So when we were looking for the data set to share yesterday, we also found the Tidy Tuesday repository on GitHub, which had data from 4 or 5 years. Anything from that we should be
yeah. I think we can look at another resource of data. Yeah. Okay. Maybe we can work on Quarto today. Are you guys up for it? Quarto, Quarto.
Yes.
Quarto.
Yes.
Okay. What is Quarto? It's just like R Markdown, but you know the basics of R Markdown now, no? When I say
Yes,
basics,
sir.
I mean the basics.
Yes.
You know what is a YAML by AML. You know what is a code chunk. You know how to make a heading, small level, this thing, and things like that. I hope you know all of that now.
Yes.
Do I have
Yes,
to repeat?
Yes, sir.
No, sir.
No, sir.
No, sir.
Now, Quarto is a similar kind of, basically it's based on R Markdown itself. But one of the major powers of R over Python and other softwares was initially this R Markdown. Because with just one format, you were able to create books, websites, blogs, packages, everything using just one format, even presentations and things like that. But soon R Studio realized that it needs a better reach than just R users. So it needed to bring in Python users, other C++ or Stan or other programming language, Julia users within the R community. So they renamed R as POSIT. POSIT. Okay. How many of you have heard of this?
The primers
This
you
is the
shared is
primer that you shared.
The primer.
POSIT. Okay. Not POSIT one. POSIT.co. It's a, if you look at it, it's open source data science company. It used to be called RStudio earlier. Okay. Now they have rebranded themselves as POSIT. And if you look at analyze, see tidyverse, ggplot, tidyr, per, in models, TensorFlow, tidy models, Spark, Shiny, Quarto, R Markdown, Flex Dashboard, Plumber Reticulate. Actually, we move beyond Sparklier now. There is a better way to actually integrate things. Yeah. Anyway, when you have time, go through this website. Many of the things you will not understand. Okay, but if you understand, it's great. But just get familiar with, okay, these are the terms that they use, right? Whatever we are trying to tell you, this is quite new. POSIT, actually, if you very quickly wiki it. Formerly known as RStudio. Huh? It's a formerly known as RStudio. Sorry, where was that? Where was the word POSIT? Yeah. POSIT. Just 1 second. If I'm not wrong.
So the 21st citation, RStudio is becoming POSIT, 28 July 2020.
Yeah. When was this?
July 20.
Less than a year.
Yeah.
Okay. So whatever you're learning from us, it's actually the industry standard. When I say industry standard, I mean that, even many of the tutorials, many of the people in India and abroad, they don't teach you this. They teach you the old way of doing things, right? But whatever we are talking about, we are actually, for example, look at this 16 number reference. What is this?
Spatial vector data, the SF that you
It's
said.
the SF package,
Right.
right? It's nothing but the SF package, and yeah. If you look at POSIT, you have RStudio, RServer, Shiny. I have not purposefully talked about Shiny, but have you heard of the word Shiny?
Yes, sir.
What about the rest? Okay, it's how we make dashboards. Okay. Yeah, but then you have R packages, Quarto things. So whatever we are trying to bring in now, or through this mentorship, is going to be there for the next. We are trying to equip you for the next 10 to 15 years from this. It might take you 10 years to actually master things or get comfortable with things, but then whatever you're going to learn now will definitely be there. It's not going to be that you learn something and then 3 years down the line it's obsolete. Nowadays things are changing, na? So Quarto, R Markdown, RStudio, everything is going to be there. Tidyverse is going to be there. Tidy Models is going to be there. SF is going to be there. It's going to be there. It's not just going to be there. It is the way. It is the future. It is going to pave the future. People who are not working on these tools or on these methodologies in the next 5 years, if they're not shifting to these tools, they'll become obsolete. They will no longer be employable.
Okay.
Okay.
Yes. Okay.
Anyway, the point being, let us now come to Quarto. I'll just give you a very good thing. I introduced you to R Markdown, right? So in communicating your research through data science, we looked at R Markdown. I'm opening R Markdown. If you look at this, it is all what we talked about, right? Analyze, share, reproduce, tell your data tells a story, tell it with R Markdown, and turn your analysis into high quality documents, reports, presentations, and dashboards. And there are n number of formats that R Markdown can give out. It can give out Word, Kindle books, PDFs, dashboards, n number of things. Now let us look at the gallery. So this is an example of a HTML file. This is what we usually get. I have not by purpose given you all these interactive visualization. Okay. First, let us master ggplot. Then it will be very easy to convert all of this into HTML or interactive visualization, right? I wanted to show you one other thing. How many of you have heard of LaTeX? LATEX?
I tried using it once.
Okay, then I will not go there, but yeah, Shiny. Yeah. This storyboard is one of my favorites. So there is a very easy way to create dashboards in R Markdown, and it's called Flex Dashboards. Okay. This is an example of a Shiny Flex dashboard. Once it opens, you will see what I'm trying to say, right? So this is all interactive. Okay, you can have this is the birthplace of art anyway. This is using the leaflet package, right? this is an extension of the SF package, right? So SF was a static image producer, right? It created a ggplot static image, whereas Leaflet is more of a dynamic HTML interactive interface. And you can have other options. You have D3 heat maps. Everything is again interactive. This is the dendrogram, right? This is again using we once worked with the MT cars data set. Remember, cylinder placement. This is nothing. I think this is this placement. This is the same data set, but you are visualizing a heat map using the D3 graphics library. DY graphs, I think I showed you this when I showed you the COVID-19 dashboard that we built. Did you guys look at that? I mean, I shared at one session, I showed it, no?
Yes.
Yes.
Yeah, this is a similar thing. You can have interactive this thing, you can zoom in, zoom out, all of that is possible. You can have if you remember in yesterday's lecture, we were actually looking at the fluctuation in the CPI, consumer price index, right?
Yes.
We were also thinking what we did a smoothing parameter. We did a geom smoothing and it came smooth. We can also do a moving average. We can have a small window here and say that, okay, we need a 10-week moving average, and then it will smooth it according to the moving average. All that is possible. And then if you remember, I also showed you a Plotly library once. Did you do you guys remember? Plotly. There was an interactive 3D visualization that I showed you. Anyway, yeah, it's. Did
Around the time that you showed GT summary only.
I think I showed you. No? Yeah, this became obsolete. Data is not even updated at the ministry level now. But yeah, I'll just try to show you the 3D visualizations. Yeah, and then animations and all have I showed you?
No.
Okay, let us. There is still a lot to go through there. Huh? And these are examples of books using R Markdown alone. I'll show you an example of a website that I've created using R Markdown. Okay. Do you want to see?
Yes.
Yes.
Your PHDMI website, have you seen?
Yes, sir.
Yes, sir. Yes,
That is made using R Markdown. Okay. Everything that you're seeing here, this is all R Markdown.
Okay.
Not only this, this is R Markdown, 100% R Markdown.
Okay.
Okay. Not only that, the slides are also made in R Markdown.
Okay.
Some of these slides you might have seen already, na? These you have seen, na? I might have shown all this. Some of these at least.
No.
You have seen, no?
Yes, sir.
Yes.
Reproducible research spectrum.
Yes, sir. This one we have seen.
All of this, this table is made in R Markdown. Both the tables, in fact.
Okay.
You need not restrict histograms to be a plot. You can embed it in a table. You see a box plot,
Yes, sir.
and I took a screenshot here, but all of this is interactive. I mean, the moment you hover over it, more details will come out on that.
Okay, sir.
And this is the example of the data set. Yeah, we used R to actually prepare an app for classifying a OCT image into diabetic, hypertensive, or 4 other categories. Yeah. So, yeah. You also, yeah. I think I've showed you this. This is how we have estimated the effective reproduction number of all the states in
Yes.
Yes.
India.
Yes. Sir.
Yes,
And
sir.
this is a Plotly object. Okay. This is what I was talking to you about when.
Okay.
So this is also Plotly library. This is also created using Plotly. Okay. So imagine that. See, we usually tend to think of writing research as a static document, writing plot in a Word document using Zotero or Mendeley and putting your references and all of that, isn't it? But now there is n number of ways you are empowered, and you don't even have to move away from that RStudio window. Okay, and in fact, all these logos and everything also has been created in RStudio only.
Oh.
Okay. Show you photo gallery. Quarto, I like Quarto much better because Quarto allows you to actually have multiple. I mean, even R Markdown allows you, but all these are examples of using gallery. This is a 1-hour tutorial that can mix it. What I ideally wanted you guys to do is, take a data set, create something like this, tell a story. It could be as simple as this. Do you want to look at the data source? I mean, the code for this? Very simple. How many lines
Okay.
of code? I don't mean
One
just
minute.
for this particular thing, the whole dashboard. How many lines of code it required? 118. That's it.
Okay.
And let us look at the data. I mean, the script. This is YAML.
Yes, sir.
Yes, sir.
Okay. What is this going to do?
Gives a
It is
description.
loading
of-
what library?
Leaflet. Sorry, let's run.
Okay. And then you are saying 3-level header and you are saying leaflet is a script of so and so. Where is that coming from? Here. Then subsequently, you are giving the leaflet, you are adding the tiles, and you add the marker. This is the birthplace of art.
Yeah, at this point, I remember one doubt, sir. Actually, during working in this R Markdown, I tried to change the color. It says it can't be do in R Markdown, so I used that HTML links to do that.
Yeah.
It
Yeah,
is a usual way of putting it.
Yeah, it always helps if you know some tricks and tools, right? Like for example, knowing a little bit of HTML will work wonders. HTML, CSS, or LaTeX, any of this, right? If you know a little bit of this, will actually take you to that, give you that freedom to not Google. But otherwise, you can just Google and copy paste and work it out. That's a different thing. Actually, Googling things is also, I know a person who has put Googling as one of her skills in her CV, and she has already also got the job also. Yeah, anyway, but yeah, what I'm trying to say is that look at this data set. I mean, you might not know the syntax for this, but let us look at the library plotly, you are actually creating a ggplot object, and you are saying that take this plot and put it into the ggplot. That's it, and it has created this graph for you. It's interactive, na? You just hover and it actually tells you things. And yeah, forget about all these other libraries. But what I'm trying to say is that even knowing a simple, even yesterday's exercise, you can very easily, very simply, very quickly make a dashboard like this. It hardly take you 10 minutes. But to get there, I would want you to actually do the 3 Venn diagrams together. Okay, should know some statistics, some computer science, some domain expertise. Domain expertise, we are trying our best. Okay, statistics also we are trying our best. Computer science also we're trying our best. But sometimes trying our best might not be enough. You need to try a little harder. Okay. Again, the point of me, I don't want to demoralize you or saying that you're not doing well. You should do better and things like that. And I'm saying you'll definitely get there. But the faster you get there, the more fun it'll be. Okay, and you'll all get there faster only when you start working together. You should stop, working in silos. You should, interact with each other, take the opportunity to actually discuss and say that just like Parthy, you were having a doubt now, everybody else also might have those doubts or similar doubts, and amongst you yourselves, you can discuss those. I know it, much of the time I'm taking to rant about things, but other than that, also, if you have any doubts, you have to put it on the WhatsApp group. I make it a point that irrespective, I reply to my wife's messages. I take time to reply to any of the queries and these things that you have. Yeah, I'm not saying that you should be grateful for that. I'm saying that we are that committed to help you out. So you should use the best. You should use the time more. Yeah. Okay. I think that I will leave you today. I don't want to confuse you with Quarto. What I'll do is I'll give you time to work on an R Markdown file. That anything of your choice, it could be the same thing that we did, a little more expanded. But what I'm going to do next time is that you're going to share the R Markdown with me, and we are going to build a interactive visualization tool, just like what we said. Okay. Maybe it could be a Flex dashboard. One can be a interactive HTML document, and maybe one thing we'll convert it from an R Markdown to a Quarto and see how easy it is. Okay?
No.
But for that, I need the mal masala. Okay, you cannot come here and say that, okay, it's not like everything I should do. Nah, something you have to do homework and come. Okay.
Sir.
I would encourage you to work together. I don't know why you guys are not. Maybe we did not have a very good icebreaker, I guess.
No, sir, we are discussing among ourselves, like mentees.
We started to discuss.
Okay. Yeah. I think, discussion is good. Yeah, I think one other thing I wanted to mention, since Lokesh is also here, Lokesh, we're planning somewhere around 2nd or 3rd week of August.
Okay.
Okay.
So the date is final.
Yeah, the date will be final by the end of this week. I hope so. Dr. Biju has to get a slot for his visa because we are traveling in September 1st week, and we want to have even if it is not for others, we want to keep it in house. Okay.
Okay.
Yeah. Let's see. I'll stop now. And I would encourage any kind of questions you have. You can just message me. Even if you feel shy to do it on the group, you just message me. Okay. I know that some of you have done it, but I would like to see more engagement from your side.
Okay.
Okay.
Yes.
Okay. Do you want me to share any of the resources that I showed you today?
Just links to the book that you mentioned.
Yeah. Modern Dive is good. But then that requires for you to have a thorough understanding on statistics, because these and all I think you will be able to grasp. But yeah, let me share this with you just in case. If you guys find it interesting, let me know. I can share more. I'll just put it on the group. Is that okay?
Yes, sir.
Yes.
I'll share one more then. If you guys are not what, let us go back to I would want you to go through the Markdown. Okay. Maybe that will prime you for doing things. So if you go through this and a couple of, not just this, you go through some of this, right? Like you have how Markdown works. This all you already know. Let me be very clear. You already know everything. Okay. Maybe not everything, but yeah, you know enough to actually understand everything. Okay. Only thing is that you're not doing it on your own. You know, reading about the theory of pedaling is different from cycling. Unless and until you fall down and scrape your knees, you will not understand how to really learn how to. There is a very bad saying in I don't know which language, but yeah, you know, you cannot learn how to ride a bike without falling down, and you cannot smoke a cigarette without coughing. Okay, so yeah, I would like you to either cough or fall down, do something. Okay.
Yes.
Okay, great. I'll stop now. Yes,
Sir,
yes. Yeah.
no, sir, it's about my laptop. So can I? Sir.
No, I already given you suggestion. No, beg, borrow, steal.
No, sir, I'm planning to buy that. So I just wanted to ask about it.
But buy is not an option now. Only beg, borrow, steal.
Why, sir? Buy? Sorry.
No,
I
I'm just
didn't hear.
joking. If you have to buy, I go for an i5 which has at least 16 GB RAM. Those are the, and preferably an SSD. 1 TB SSD would be great. What is your budget?
Well, this one is like around 58, so I can go higher than that. Maybe 80 is also okay, I think. Like my colleagues have.
Yeah, in that case, what you would like it light?
Yes, sir, lightweight and preferably touchscreen. Like I read with the touchscreen. If it's, I have to check.
Dell XPS is very good.
Okay, I think you had send the same thing only. I think Dell XPS.
Yeah, I've used Dell XPS series and I really love it. The only reason I am not using it is because I don't have the money to buy.
Okay.
I think you have the money, you can buy it.
I thought like anyway, it's like 4 years and it's fully gone now. I don't.
Yeah, yeah. Dell XPS is very good. The last Dell XPS I used was for 9 years.
Okay.
Only one issue with XPS is that it might have some the killer wireless internet connection card issues, but I was able to work with it and I changed the card. It won't really be a huge issue. Okay.
Okay.
In fact, me, Gurpreet sir, and Biju sir, all three of us had used Dell XPS. In fact, Gurpreet sir and Biju sir still use XPS. Yes.
Okay, sir.
Anything else?
No, sir.
Okay then. Yeah. Thank you. See you.
Thank you, sir.
Yeah, go through those. When are we meeting again?
Preferably in the weekends or Sunday or Saturday.
Hmm.
Then we will discuss in the group content. That must be a good option.
Yeah. Okay. If possible, we'll make it during the day.
Yeah.
Okay.
Yes,
Because-
sir. Weekend days.
Yeah, I'll be traveling. I'll be in Hyderabad. Let's see when we can find time. You guys are free on Sunday, na?
Yes, sir.
Today Sunday.
Yes.
Yes, sir.
I might have some meetings. Otherwise, but you guys can suggest. I'll make time. Don't worry. Okay.
Okay, sir. Sir, last time Gurpreet sir told me to select an area where I want to work.
Yeah, Anand, for you, I feel that we can let you work on some of the projects that we were thinking about. Okay. Because for you right now, if I ask you to think about something, you'll put too much effort on that and it will not be very productive. If you already have something, then you're great. Okay. Do you have something?
No, sir. No currently, no currently working data. I have to select a new one, and
Okay. From what I gathered is that for you, something that we are working in, because you are here in Chitra itself, right?
yes, sir.
We can have some of the project work that we're doing. Maybe you can learn from that at least, right? And that way you will have support in terms of, because you don't have a partner right now. You know?
Yes.
So we can guide you on that. Or when somebody joins, we can think about, we have some MPH students who might, whom you might, pair with, because they might help you out, because much of the learning will be accelerated when you work as a group, right?
Okay.
By
The,
seeing
from
it,
the new batch.
not the new batch, some people who are passed out. Yeah. Passed out. They've already been working in some places and they're also interested to join in. So maybe we can pair you with them. I'll have a word with Dr. Biju and see. So for you, I think if you have something in mind, that will be good. But otherwise, as an alternative, we can keep that. Okay. Okay. Do you have something in mind? Why don't you explore? You can come up with your own this thing. Okay. Maybe we can have 2 projects that you can work on. That's also fine.
Okay. Anyway, let me check.
Yeah, you can think about it.
The
Yeah. Anything else?
no.
Okay then. See you.
Oh.
Good night. Take care. Bye.
Bye.